Hey guys, here's a new video on the QuickShifter, and I'm gonna show you my new toy. This is for revving the engine of the motorcycle. I ended up doing four, but I only need one, so those three extra boards are just gonna be there for backups, and obviously one's gonna be for my CVR. So let me show you what the changes are for the final revision of the QuickShifter. As you can tell, it does not have a tiny 85. It has an 84. So, um, the difference is that well, there are a few changes. So first is the processor. I got a processor with more pins because I wanted to have more control over uh, the the top and the bottom of the H bridge independently of each other, because there is a slight delay on turn off uh, from the N channel and the P channel. So switching them at the same time doesn't mean that they're gonna turn off at the same time, and you end up having a straight through connection from power to ground for about 10 nanoseconds. It's not a lot, but you know, it's it's something. So I decided to go with a bigger processor with more pins, so I can have one pin per gate. So I'm using 4 pins to control all of the gates of the H bridge. So I have the left side P channel, N channel, and the right side P channel, N channel. I'm also using 2 pins for LEDs, just so I can it gives it an effect of which side is firing, and I think it looks pretty cool. Also helps with debugging. Other than that, it's about the same. So if we look at this one here, now this one has its own its own pin, and this one has its own pin as well, and they're both connected to ground. Technically 100k resistor. This is just in case we end up not connecting this one, it'll always be off, just as a safety mechanism. Both of them will always be off. Same on this side, they're identical. I ended up removing the small capacitor here, the 1 microfarad capacitor. It turns out I didn't need it. The system is noisy, but I found a better way of compensating instead of having one here, since I was running out of space. Um, the So these are my 2 LEDs, just for visual cues of what's going on. And this is my um, regulator. Man, I keep forgetting those things. So this is the one I'm using. I'm using the MCP 1755. Is this the one? No, I think I do with it. Here we go. This is the one I'm using. It's 300 milliamps, although I'm only using about 100 milliamps. This is the for 200 milliamps, 5 volts, and the input can be up to 16, which is good enough. The motorcycle should never go above 14.5 anyways, so we're good. And so let's go back to this one. So that's the schematic, pretty simple. It's almost the same as the original video. The difference is that I'm controlling each of the gates individually, so I don't have one that turns one off and the other one on. So I can have all of them off at the same time. Before, it was either the high side was on or the low side was on. So this way I can control them individually, which also means that you have to be a little more careful with the coding, because if you end up turning both of them on at the same time, then you end up having a straight path to ground, and it will blow a fuse on your motorcycle. So processor is the tiny 84. Let's go look at the layout. This is the layout of the board. So uh, so as you can see, that's is the hold on. So it's the same thing. Uh, one of the, I guess one of the key things that you have to pay attention to this board is since it is a noisy system because of the coil firing, you have to have um, your diodes here with the output connected to voltage, just to eliminate the ringing, but also you also need enough capacitance here by your regulator. This is your regulator here, so you have to have enough capacitance on both capacitors to this one and this one. Highlighting. So this and this. 2 microfarads are good enough for the system. Don't go lower. You might want to go higher if you're having issues, because it draws a lot of power when it fires, and if you don't have enough, it will drain it below the threshold, and then it'll start ringing, where your voltage, your 5 voltage, will become unstable with a lot of noise, and causing the processor to reset. So you want to have enough capacitance there, and obviously the actual board looks like that. uh, Issues that I had with my board, let me show you what they are. So I let me get something here. So this diode here, this is the 12 volt connection, and it goes to my power supply, my regulator. The This line that is coming from this end, I didn't connect it here. I forgot. I put the vias and I connect them at the top, but I did not connect them at the bottom. So I ended up to putting a wire to go around it. I couldn't put a wire through the via because it's 3.5 millimeters, 0.3.5 millimeters, so it's too small for any wires that I have. So I ended up putting a big wire around it. It's red, so you can't really tell, but all the boards have the same issue because they're all the same. They don't all of them in one batch. So that's the only issue that I have. It's coming around. If I was to redesign this board, I would probably get a ground from this capacitor and these two MOSFETs all the way back to the source. I wouldn't be going through the regular plane, because it makes it a little bit noisy. Other than that, it's good. Let me give you a demo of how this thing works. So let me plug in. We have our gear positioning indicator or sensor, and we have our QuickShifter. So let me plug this in and move this out of the way. And, let's see. Oh, okay, so now we have 4 plugs, so, well, 5. This is power and the 2 coils. Throttle. We have the shift sensor and the gear positioning sensor, and this is the new one. This one, I'm getting power. I ended up redoing this connector because I'm getting power, 12 volts to go back to this unit because this requires 12 volts. Power and ground from it. So as you can see, I'm running it through the back, and then I'm getting that little connector there. I don't know if you can see it. Let's see. This green wire, which is the blipping the engine. And actually, let me show you what that one is. Let's get the board up. Hold on. So is this connector right here, which is I believe it's PC2. Yeah. So now I'm using all my connectors. I'm using my throttle, blip in the engine, my shifter, and the gear indicator or gear positioning system, I guess, GPS or sensor. And nothing has changed on this board, so let me go back to the other one. Where is it? Right here. And obviously I have my board for doing a batch of 4, but this is the original one. Okay, so let's go on with the demo. So let me plug this in. This one. And I don't need to plug anything else other than give it power, which I have here. And I need a ground. I have my actuator here, and I am going to connect this to that one. Let me get my application here running. Right, there it is. That thing, power up, and you can see we have power. So if I press start, see, you can see the lights, but you also see this thing going out and coming back in. So very nice. So that means that I can rev the engine from my phone, and I can also rev the engine from the sensor as well. You can see it's pretty stable. The code for the rev sensor is this right here, and it's pretty simple. It's close to what I showed you before for the a tiny 85. Obviously this one, since I'm using more pins, you have more pins, more registers being changed on port A and port B. These are the two for the LEDs. Turn both of them off. Are those the LEDs? No, they're not. This is I believe is the high side. Let me see. Oh, is a top. Okay, so where is it? So right there. So, well, let me go to the main loop. So on the main loop, I'm just setting the pin directions for 3 pins on each of the ports. The first 2 are for the LEDs. This is for the high side, and these 2 are for the low side. And I have everything in functions. The reset actuator, which is this function here, it turns off the high side, waits 1 microsecond, since the delay for turning it off I think is like between 10 and 30 nanoseconds, so more than enough. And then I turn off the bottom side, and then I turn off both of the LEDs as well. I don't need this delay here. I can just turn this off, but that's what I have, so I'm gonna leave it like that. And then I'm just going in a loop, checking to see if I'm revving, if my shifter is telling me that it's time to rev the engine. And you saw this function before. Obviously it's a different pin now. It's on pin 3. So if it's on, if it has voltage 5 volts, then I assume that I want to rev the engine, and I call this function open throttle, which is this right here. It calls a reset actuator just in case something's on. We don't want to burn the unit or blowing a fuse just by turning everything on. So we make sure everything's off, and then we turn the LED. That will be the green LED, and then we turn the high side, and then we turn the low side. Uh, so once we're there, while we're revving, or while the main unit is sending the signal to say keep revving, it's gonna do a loop, and in every loop it's gonna wait 1 millisecond for a maximum of 300. So it's about 300 milliseconds max that you can rev the engine, and then the unit will stop revving the engine. So it's either if it reaches the maximum, or the unit signals that it's done revving the engine. So this is just for safety. Once that's out, it closes the throttle. That's another function. Same as before, resets, turns everything off pretty much, for the high side and low side on both sides, left and right. Then it turns the LED, the orange one on the bottom side, it turns it on. By the way, this one will turn off the LEDs as well, and this one will turn on the orange side, or the bottom side of the board, and then it turns the bottom, the high side now of the blue wire, and then the bottom side as well. So it's just the opposite. So it reverses voltage, so the motor spins the other way and pulls it in instead of pushing it out. Once that's done, then I wait 100 milliseconds and reset the actuator. So what this is doing is pulling back for 100 milliseconds. So just to make sure that it's pulled all the way back. You may want to lower this. Well, I might want to lower this number because that's a solid number. It doesn't change. And if I need to downshift even quicker, then I may have to reset this to something lower, because you will have times where you have to downshift really fast, 5 gears within a second. And then it resets the actuator. It checks to see if you still have pressure on the shifter itself, and if you do, then it just stays stuck in the loop until you release it. So you don't want to keep revving the engine just because you kept your foot on it. So this is the for the little board that I just showed you for the I don't know what you called it. It's just for revving the engine. And obviously the main code, this one has changed quite a lot. It has a lot of code, mostly for changing settings from within the phone, and saving it to a processor. I'm not done writing all the code, so I'm not going to go through it right now until I'm done writing and make sure that everything functions correctly. So that's the code. So what I want to do now is I want to install it really quickly on the motorcycle, and rev it with my phone, and also rev it as I'm downshifting. So bear with me, and I'm gonna leave you with while I do that, I'm gonna leave you with this schematic so you can copy it. I don't know if you need to see the processor, but you definitely need to see this board. Well, the H bridge is the most important one, so that's the one you wanna take note of how everything is connected. Alright, so let me power this thing off. I already installed one of the actuators, another actuator on the motorcycle. I will show you how everything's connected on a separate video, because right now it's getting late and I don't want to take it apart again. So let me plug everything back in, and let me give you a view of the processor as well while I connect my thingies. Right. All done, almost done. I'm not gonna have it nice and neat. I'm just gonna have everything connected so we can do a test. this. Correctly. Where's my unit? Here it is. So I have my gear indicator, shifter. Let me give you a preview of the rest of the stuff right here. There it is. Throttle and drive and power. All right. So I'm not sure if you're gonna be able to see anything, but let me put the light on. So that's my motorcycle. Here's everything connected. Here's the rev already connected to an actuator that is installed. Right, here's my little toy. And everything else is connected. Here's the other one that I had to make to detect the gear. And here's the app again, ready to go. So let's turn on the motorcycle. So let me go back to what I had on this one, and if I press it, it needs to connect. Hold on. There you go. So if I press the button, it revs the engine. Let me see if you can see the throttle moving just a little bit over there. Right there. So, oh well, there. So very little. Alright, so there it is. So back to this one. You see that? Right? There it is. Here's the shift sensor. There's a down. That's the up. So if I put it in gear, and if I press down, you can hear it. It wants to rev, but I'm not moving very fast. Hold on. Now for this to work, you have to be going at high RPMs, and obviously you have the engine has to be stressed. Not the engine, but the gears. So you have to be loading into the gears for this to work properly. Otherwise, it just, you know. Right, I'm pulling on it, pressing on it. So there you have it. Okay. So my goal here is to have this unit fully functional from within the phone. Right now I can see everything the unit is doing. And I have my gear positioning system in voltage. Also, I have it in uh, right here in number. I have my shift with two limiters. If I wanna downshift, down. If I wanna upshift, I have my throttle. This one is not. Oh, actually, it is functional already. So the for the rev to work, uh, it needs to go below the top line. So that means your throttle needs to be somewhat close or fully closed. You don't want to rev the engine while you have it fully open or somewhere, like halfway going through it. So if it's closed, it'll rev it. And the bottom one is uh, for downshifter, for cutting the ignition if you want to shift while you're going. So that means that the throttle needs to be open or somewhat open in order to cut ignition. Otherwise, what's the point if you're not putting any load on the gears? We have our odometer, not odometer, but anyways, our RPM indicator, and it's telling us everything about the RPM. We have a message for shifting, so if it's shifting or not, it'll say yes or no. This is just for to make sure that the aside from this one showing you that it is present, it's also going to shift as well. So this is just for debugging purposes. And this map A and map B and this the inactive map is not working right now because I don't have the code for it. But the idea here is that I want to have two settings: one for riding the racetrack where it has to be aggressive, and one for cruising on the street where I want it smooth. I don't want any jerkiness on the motorcycle. I just want it to cruise and be very smooth as I'm shifting up and down. Um, I plan on making another. Well, I'm gonna have another screen for just specifically for the settings because there are so many settings that you can modify. But I need to finish the code on the back end on the unit itself before I can have another screen for that. And that on the phone should be simple to just lay out the screen and put the buttons and whatever controls I need to have. But the code on the back end is gonna be a little bit tedious because it's a lot of repetitions. So once I have that, I'll give you guys a walkthrough of the entire code on how everything works, and also how it connects to the phone. So that's uh that's all I have. Enjoy. Oh, obviously, the next video will be showing you how I have it installed on the motorcycle, and uh, you know that's about it. I'm not sure what the next video is gonna be. Uh, Actually, I do have another project that I need to do, but I don't know if I'm gonna continue doing it with the Atmega processor, or just gonna go straight to ARM or ARM processor. Other than that, we'll see. We may do the other projects that I've done in the past, which is one is a heads-up display. Since we are already getting the RPM and the gear, it would be pretty cool to be able to display that on your helmet, so you don't have to look down. Right? You should be able to see a bar of lights across the helmet, across the visor, and also a big giant number reflected on that visor, telling you what they are. And also, when you get to specific RPM, let's say you're getting close to red line, it would be pretty cool to have that bar of lights start flashing. So you only focus at what's in front of you, and if it starts flashing, you shift again. All right. So, all right, now this is it. That's all I have.